Hello, a very good day to you, lecturer. Before the video presentation begins, I'll show you what our group discussed as a team in the WhatsApp group. As you can see, we divide the task, we set a due date so that we all can compile the slides together, and also the video. We also discussed the entire assignment as a group in a Google Meet meeting. So without further delay, here is the video presentation.
Hi everyone, we are from Group D. Today we would like to share our presentation topic with you, which is run with link and exchange group instruction set. I am the first presenter. My name is QUAN AC16002. Now I will explain what is branch. A branch is an instruction in a computer program that can cause a computer to begin executing a different instruction sequence and thus deviate from its default behavior of executing instruction in order. It may also refer to the act of switching execution to a different instruction sequence as a result of executing a branch instruction. And branch instructions are used to implement control flow in program, loops, and conditional. A branch instruction can be either an unconditional branch, which always results in branching, or a conditional branch, which may or may not cause branching depending on some condition. It has four main types of this instruction set. First is branch, second is branch with link, the third is branch and exchange instruction set. The last is branch with link and exchange instructions. The operation of this instruction set is all this is instruction cause a branch to label or do the address contained in RM. In addition, the BL and BLX instructions copy the address of the next instruction into the link register, which is R40. The BX and BLX instruction can change the processor state from ARM to STEM or from TEM to ARM. BLX label always change the state BXRM, and BLXRM derive the target state from bit 0 of RM. If bit 0 of RM is 0, the processor changes to or remain in ARM state. But if bit 0 of RM is 1, the processor changes to or remain in TEM state. Next is the restriction of this instruction set. Remember that do not use the stack pointer of program counter in the BX or BLX instruction. And next is for BX and BLX, bit 0 of RM must be 1 for correct execution. V0 is used to update the EBSR T bit and is discarded from the target address. Branch can be conditional or unconditional. Let's see the table. Branch always labels in capital letter B. For branch unconditional, it is only B and it is always take the branch. But for branch with conditional, an instruction with a condition code is only executed if the condition code flags in the CPSR meet the specific condition. It means that, let's say, instruction number 3, BEQ. EQ means the condition equal. And after we compare the result and before the branch is taken, we must confirm that our flag value set must equal to 1. If set equal to 1 and the branch is taken, if set is 0 instead it is not meet the requirement and the branch is not taken. If the branch is not taken, it will continue to the next instruction.
Assalamualaikum. My name is ALIF AIMAN bin SHUHAIMI. I want to explain about branch and I'll continue from the part 2. For the first branch is PL, it means plus. Conditional test is n equal to 0, it means if the result is positive or 0, the branch occur. If not, if the result is negative, ignore the branch. For next branch is BGT. BGT means greater than. The conditional test is N and V must set or clear and Z is clear. The branch occur if the comparison is greater than. The last branch is BLE. BLE means less or equal. The conditional test is N set and V must clear or N clear and V must set. Both must N and V must not same, but and Z is clear or the comparisons the branch execute if the comparison is less than or equal. Next, I want to explain about the syntax of B condition. For the first must B and code label. Labels mean the branch. B is the branch and code is for example GE, PL, B. There's another code for the branch, and this is the instruction. And if the branch true, the condition is true, it's go to the label. You skip these instructions. For example, compare RO and stack O. Use BGE means greater and equal. If the comparison is true, the condition, and skip the BGE B and goes to the branch A and goes for the after A branch instruction. For example, A, D, H, R1 and R2. So that's all my part.
Okay, now let's move on to the next instructions, which is BL instructions. Okay, BL instruction is branch and link. BL instruction copies the address of the next instruction into the link register, and it causes the branch to label. Okay, finally, it can cause the instructions even if the label is out of range. Okay, you can see the example next to it. Okay, so that's all for BL instruction. You can see the simulation in the last slide. So thank you.
Assalamualaikum and very good morning to our lecturer and my friend. Today I want to present about BS instruction. BS instruction is branches to the address contained in a specified register. The value of bit 0 of the branch address determines whether execution continues in ARM state or thumb state. Bit 0 of an address can be used in this way because first, all ARM instructions are word aligned. This means that bits 0 and 1 of the address of any ARM instruction are good ignored because these bits refer to the half word and byte part of the address. Second, all thumb instructions are half-good aligned. This means that bit 0 of the address of any thumb instruction is ignored because it refers to the byte part of the address. PS instruction is implemented on thumb-capable ARM processor only. For syntax, RN. For RN is a register in the range R0 to R15 that contains the address to branch to the value of bit 0. In this register determines the processor state. First, if bit 0 is set, the instruction at the branch address is executed in thumb state. If bit 0 is clear, the instruction at the branch address is executed in ARM state. For condition is an optional condition code. Only the ARM version of BX can be executed conditionally. For thumb weak write encoding BX are end to end. For ARM context, we write a BX and bracket, we write a condition and we put the RN. For usage, you can also use BS for branches that do not change state. You can use this to execute branches that are out of range of the normal branch instructions. Because BS takes a 32-bit register operand, it can branch anywhere in 32-bit memory. The B and BL instructions are limited to 32 MB in ARM state for both conditional and unconditional B and BL instructions. Next, 4 MB in thumb state for unconditional B and BL instructions. And lastly, negative 128 to positive 127 instructions in thumb state for the conditional B instruction. For notes, the BS instruction is only implemented on ARM processors that are thumb capable. If you use BS to execute long branches, your code will fail on processors that are not thumb capable. The result of a BS instruction on a processor that is not thumb capable is unpredictable. Changing the assembler mode. First, the ARM assembler can assemble both thumb code and ARM code. By default, it assembles ARM code unless it is invoked with the 16 options. Second, because all thumb-capable ARM processors start in ARM state, you must use the BS instructions to branch and exchange those thumb state, and then use the code 16 directive to instruct the assembler to assemble thumb instructions. Lastly, refer to the ARM Software Development Toolkit Reference Guide for more information on this directive. And this is the coding for the BX instruction. And that's all from me. I pass to another teammates. Thank you.
BLX is a branch with link and exchange instruction set. Syntax. Example, ALF bracket condition bracket w bracket level. Next, BLF bracket condition bracket RM. Condition is an optional condition code. Condition is not available on all forms of this instruction. .w is an optional instruction with specifier to force the use of a 32-bit BLX instruction in count, while label is a desirable expression and YRM is a register containing an address to branch to. It's the BLX operation. The BLX instruction forces a branch to label or to the address contained in RM. In addition, the BLX instruction copies the address of the next instruction into LR. It means R40 and the link register. The BLX instruction can change the instruction set. BLX label always changes the instruction set. It changes the processor in ARM state to thumb state or processor in thumb state to ARM state. BLX-RM derives the target instruction set from bit 0 of RM. If bit 0 of RM is 0, the processor changes to or remain in ARM state. If bit 0 of RM is 1, the processor changes to or remain in thumb state.
Hello, I'm Chobowen, and I'm going to continue the presentation from Group D. Now I'm going to simulate all the operations that my friend has discussed earlier. Okay, first, this program, just as an example, just random operations in it. Okay, now on to the B, branch. Branch L, you jump to L, as seen in line 16, jump. It skips all the previous steps, and then continue, and BL. BL is basically same like branch, you branch to Y, but the difference is if you save the next operation into the link register. The next operation will be the 28, it will be saved in LR, and then it will jump to Y. 3, 2, 1, go. As you can see, link register has been updated with 28, which is the line instructions saved at this address. And then you jump to Y, the X. BX is used to jump back to the link register, as you can see here, LR, BX LR. So you jump back to line 19 to complete the task, since it jumped over just now. Okay, see, jump, and then compare, and then now for the branch conditions. Branch with conditions, meaning you check the NZCV here, see if the condition is met. If it's met, you run the operation. If it's not, you will not run the operation. So in this case, since R0, R1 is not the same, it would not run, and you run not equal. When you run not equal, you jump to not equal, and then run these operations. And since not equal is already done, you jump to stop. And now on to the next example, which is the application of branch instructions. As you can see from this flow chart, this branch instructions set can be used to sort data. Like this is an example for student marks data. You can resort to 180, which is here, or grade B, grade C, or grade D, or even after, if it fails all condition, it will store in grade F. On to the KL. This program follows the flowchart I showed earlier. In this case, we will write the student data, which is 60. Okay, we store the data, initialize it, and then we compare with the grades itself. In this case, the first compare with 79, since it's not greater, 60 is around, is here, compare with 59. Since 60 is more than 59, this BGT will run. So if we jump to CG, which is located at line 124 here, and then it will run that program, which is to move that data set into the address here, since 3C is equivalent to 60 in hexa, and then we'll store the grade here. Okay, you can see here the memory. This student's data 60 marks is grade C. Yes, this explains the functions application of B branch instruction set. And in conclusion, this branch BL, BX, and BLX instruction set is used to break the flow of the program so that it can run the program in a way that you want to run, depending on what the data is input, what the inputted data is. Thank you.